We're going to prove the following fact. If you have a polynomial of degree n where an and a0 are not 0, neither of them are 0, and then you reverse the coefficients, that is, you put an first and a1 second, and the last one is an. If x0 is a root of one of those polynomials, say p of x, then 1 over x0 is a root of p star of x, the one where things are reversed. Now, x0 cannot be 0 because of this constant not being 0. If x is 0, then that term would be 0, and that term would be 0, and all of those terms would be 0, and this term would be 0. You add up all those zeros, you get 0. But then when you add on the non-zero number a sub 0, you get a sub 0, which is not 0. Hence, 0 is not a root. So we don't have to worry about, oh, you can take the reciprocal of x0. Yes, you can. Okay. Now, so suppose x0 is a root of p of x. Okay. Now, let's look at p star of x. P star of x is our a sub 0 x to the n plus a1 x to the n minus 1 all the way down to a sub n minus 1x plus a sub n. Now, if we factored out x to the n from every term, we would have x to the n times a0 plus a1 over x. You know, let me write that differently. A1 times 1 over x all the way down to a sub n minus 1, 1 over x. This should be n, hold on. Okay, n minus 1 plus a sub n over 1 minus a sub n times 1 over x to the n. Now, just reversing the order, we have a sub n 1 over x to the n plus a sub n minus 1, 1 over x to the n minus 1, all the way down to a1, 1 over x plus a sub 0. Now, when I said reverse it, I didn't just, let me see where we are. I didn't go from this polynomial to that polynomial. Here, I just reversed the a sub n's from p of x to p prime of x. Here, down here, I just put this last and this next to last, that second and that first. Okay. And this is p star of x. But if you notice something, so now, when we're finding zeros, it's not going to come from this factor. Because this time this is 0, at least we want to find out when it's 0. Normally either this is 0 or this is 0. But this is only 0 if x is 0. And we're saying because a sub 0 is not 0, then 0 is not a factor. 0 is not a root. I meant to say 0 is not a root. Okay, so the root comes from here. But if you notice, this is x to the n times this but that's just p of 1 over x. And this equals 0 when 1 over x is x0. Or I should say, here. It does equal 0 when 1 over x equals x0. But that means that x, taking reciprocal of both sides, is 1 over x0. So I showed that if x0 is a root of p of x, then a root of p star of x must be 1 over x0, which is rather interesting. Now, although I'm just into theoretical mathematics, pure mathematics, this actually can be used to make things easier. I'm just going to randomly put down a problem. Well, suppose we have this problem. X squared minus 5x plus 6. We want to know when it's 0. In fact, we have this problem. This is the problem that we have. And we want to solve this. Now, the problem is that this has a coefficient of x, the coefficient of x squared is 6. I don't know how to factor that, but you know what? If I read it backwards, like this, I say, ooh, I know how to factor this. This is x minus 3 times x minus 2 equals 0. So x is 3, x is 2. And I go, oh, I know the answers here. They are reciprocals. Okay, so sometimes, if you're given this problem, you can think this one instead. And all you do when you get the answers is take the reciprocals, which isn't that hard to do. That finishes this video. I'm going to ask you to subscribe to my channel, tell your friends about it. See you in the next video, and as always, continue to watch my videos and learn.